Okay, so on this question, a cruise ship heads due west from a port 5 miles directly south of San Francisco. If the ship is traveling at a constant rate of 20 miles an hour, how fast is the distance between the ship and San Francisco? Changing 1 hour after leaving port, blah, blah, blah. Okay, so we got to put on our map here. We'll go here. This is San Francisco. And there's a port 5 miles directly south. Okay, so I'll come down here and we'll say this is 5 miles. We're saying this is north, south, east, west, the directions. So 5 miles directly south, this is where the port is, right? From a port 5 miles south of San Francisco. If the ship is traveling at a constant rate, 20 miles per hour. Oh, it heads due west. Okay. So the ship, I'm thinking, where's the ship going? The ship is going this way. Okay. And let's say And how fast is it doing that? It's headed that way at 20 miles per hour. And it says, how fast is the distance between the ship and San Francisco? So we'll do this. Here's the ship in San Francisco. Call that Z. Um, that's the distance between the ship and San Francisco. See, here's where the ship ends up. Okay. So the ship is going that way. And how fast is the distance between the ship and San Francisco changing? All right, so step number one, find find the rate letters. Okay, what rates do they speak of? Well, they're talking about the ship traveling. So that means let's call this X, which is the distance the ship is from the port, and that's dx/dt is changing by positive 20, right? Because it's increasing. Whenever a rate is increasing, it's positive, decreasing, it's negative, right? X is getting bigger by 20 miles per hour. I don't know if you can read this. I didn't write this so well. Miles per hour, right? So the ship is headed this way, 20 miles per hour. So every hour, X grows by 20 miles. The XDT is plus 20, it's increasing by 20 miles per hour. Okay. And what else is changing? Well, they're asking for DZDT. That's what they want to know. DZDT. There's no other rates mentioned, is there? No other rates mentioned or asked for, right? How fast is the distance changing? Yeah. All right. So that's just X and Z. Okay. Off we go to step two. And here's where we write our equation. This will be an equation relating, so related rates, relating only those letters. You can have numbers, but no other letters. Only those letters in this case. That would be X and Z, nothing else. Don't put any other letters in there. So what's that going to be? Well, that's easy, huh? 5 squared plus X squared is Z squared. Now you might wonder, can we put in a 5? Yeah, because that 5 is always 5. That's not changing, right? That's just how far the port is from San Francisco. The port's not moving. San Francisco's not moving, right? 5 miles, period. So yeah, so there's our equation. So we're going to go 5 squared plus X squared is Z squared, right? Just Pythagorean theorem, X squared plus Y squared is Z squared. So, except this is a 5. It's not Y. Don't put a Y in there because this is not, doesn't need a letter, doesn't need a variable. It's not varying. It's always just 5. The port is 5 miles from San Francisco and it's not moving. So we only have an equation with those two letters and then numbers. Step three. Now what? DDT both sides. DDT both sides. So you know the step. I'm going to go to the rate of change with respect to time of both sides. What happens here? This is 0. It's a number. It's 25. It's just 0. The rate of change of a number like 25 is 0. It's not changing at all. So it's just 25. Okay, but this part comes on down. We'll get 2x dx dt equals 2z dz dt. All right. And step 4, plug in the numbers. Okay, well, one quick thing is we can just divide out the twos right away. So we get, okay, x dx dt is z dz dt. So do we have x? Let's go find x. So to find x, we go, okay, the ship's moving 20 miles an hour. So, and it does it 1 hour after leaving port. So 20 miles an hour times 1 hour equals 20 miles. So x is 20 miles. So this ship is going this way 20 miles an hour, and it's only been going for 1 hour. It left port 1 hour ago, so it's going to go 20 miles. So x must be 20. How do we find z? Well, Pythagorean theorem, right? So 5 squared plus 20 squared, right? 5 squared, 20 squared must equal z squared. So that's what 25, 400, and this is z squared. Okay, and then we root it. We're going to go root on both sides. So then z will equal whatever that is. I don't know what that is. Why is that not? Let me see. So square root of 425. Square root of 425. So there's z, square root of 425. The distance apart from San Francisco at that moment is square root of 425. Let's bring that down. So what's x again? X is 20. There, x is 20. So x is 20 times dx dt. There, 20, positive 20, coincidentally, equals z. Z is the square root of 425. So let's put that in there. Square root of 425, and then dz dt, which is what we're looking for. All right, we are on the verge. Divide both sides by the oh, come on, square root of 425. And boom, boom. So 20 times 20 over square root of 425. Come on, Desmos. Whoops. 20 times 20 over square root of 425. So 20 times 20 over the square root of 425. 425. I'm getting 19.40285. 19.40285. 19.40285. 1985 is dz dt. Is that right? 425, yeah, 19.40285. There we go. We found out how fast the distance between the ship and San Francisco is changing 1 hour later. There we go.